So we are looking, again, I'm going to just edit the date real fast because we are doing these a day earlier than originally planned. So today is the 21st. We're doing these. Due to that PSAT, SAT test date coming up this week. So we're just adjusting our schedule a little bit. All right, so completing the square, vertex form notes. Okay, so what we talked about on Thursday and Friday last week was changing from standard form to vertex form. Okay, they're saying right here that this is called general form. We call it vertex form. So I'm actually going to mark that out and put vertex. And it says vertex form right here. Okay, so we call it vertex form because we can see the vertex. Remember, HK is the vertex. Okay, and you have your A multiplied outside, then X minus H in parentheses squared, and then plus K on the outside. Okay, so A, we'll need to recall, is our vertical stretch or compression. And if A is negative, we have a reflection. And then H is our horizontal shift, left or right. And K is our vertical shift, up or down. Okay, so we're going to go through the completing the square process to get our function. Well, first, here is just practicing the completing the square. And then we'll do an example with a full quadratic function. So let's just refresh on the completing the square process from last week. Okay, so when you've got that plus blank, you've got an x squared term, an x term, and we need to figure out what constant would make this a perfect square trinomial. Okay, how do I figure out what goes in that blank? Who remembers? B divided by 2 squared. Okay, B divided by 2 squared is what's going to be used to figure out what goes in that blank. Okay, so here my B is what? Negative 16. Okay, so I'm going to do negative 16 divided by 2 and square it. So that's negative 8 squared. I don't know why I started to write 16. All right, which is 64. So that would create the perfect square trinomial, which would factor, okay, what makes it a perfect square trinomial is that it factors to the exact same binomial twice, because what multiplies to 64 but adds to negative 16? What multiplies to 64 but adds to negative 16? Yeah, it's this number that we got right over here. It's half of B. It's negative 8. Okay, so negative 8 and negative 8. The whole point of this was to get it to where it's the exact same binomial twice. So we can just write that as x minus 8 squared. So again, remember that B divided by 2 is what goes here, not in that whole thing. Right there. Okay, let's try that one more time. Let's practice that process. In number 2, what is the B value? Just 18 is the B, right? Okay, so 18 divided by 2 is 9. And what's 9 squared? 81 would go in the blank. So that means it would factor to what? Whoa. What are the factors of 81 that would add to 18? 9 and 9. Positive 9, positive 9. Okay, that's what that B value was over here. Okay, so we can rewrite that just as x plus 9 squared. Okay, so this middle step where we're writing it as the same binomial twice, where we're actually doing the factoring. When we are doing the completing the square process, we'll be able to skip that. We'll be able to go straight from figuring out this completing the square straight to here. Okay, so let's try this in number 3. Okay, we're given a function of a quadratic in standard form, ax squared plus bx plus c. We want to rewrite it. So we change f of x, instead of equals f of x, we have it equal to 0. Okay, now what does that become? I move that -1, or that +1, excuse me, gets subtracted, so it becomes -1 over here. Okay, so we move the constant to the other side. Okay, what is the b divided by 2? Let me get my blue pen here. So -4 is my b value. Okay, -4 divided by 2 is -2. And they just want us, this first blank is just rewriting what we already have. So the x squared minus 4x. Okay, and this -1 was already there. So we have to add that -2 squared to both sides. I'm not really liking the way that they made these blanks for this, because I would have just squared that up here and then put the final constant. What is -2 squared? It is just 4. Okay, so instead of writing plus -2 squared on both sides, if you prefer to write +4, okay, instead of -2 squared, if you want to update that, that's fine. Okay, or you can keep it as -2 squared, but we know that comes out to +4. So then when we factor the perfect square trinomial, it's going to be x minus 2. So that becomes x minus 2 squared. Now on the right side, we do need to combine like terms out here. Okay, so what is -1 plus 4? It's just a 3, +3. Now, that's where we were stopping last week. When we got it here in the Delta math practice we were doing, we just stopped here. But I told you to put this in vertex form, to have it as an equation in vertex form, we want that constant moved back to the left. Okay, so what is that going to become when I move that 3 to the other side? It's going to become -3. So I'll have the x minus 2 squared, and then that 3 moved over to the other side becomes -3. So if that's my equation in vertex form, what is my vertex? What is my HK? Yeah, remember H, what this highlighting issue is. Here we go. H, K. Remember your vertex is HK, which is 2, -3. Because remember, it's the opposite of what you see inside and then what you see on the outside. Okay, y'all remember talking about that earlier last week, HK? The opposite, you change that sign of what's on the inside to get your H, because remember in the equation, it's x minus H. The minus is in the equation, so the H is just the 2. Okay, now, we can see based on our A value that this graph is going to open what direction? It's going to open up. And I can tell that because A is positive. A is the number in front of the parentheses here being multiplied, and there's nothing there, so it's an understood 1. A is a 1, a positive 1. So I know the graph's going to open up. So is this a vertex, a max, or a min? It's going to be a minimum. If the graph is opening up, our vertex is a minimum. Okay, so I'm going to go ahead and plot that point at 2, -3. Okay, so there's my vertex. Okay, now you can make a table of values, or you can use your A value to get your additional points. Okay, or you can go in Desmos and type this in and look at points there. Okay, create a table in Desmos or look at the graph in Desmos, whatever your preference is. But I know that A is 1, so I know the movement from the vertex is over 1, up 1, left and right, or over 2, up 4. Because 1 squared is 1 and 2 squared is 4. Okay, so that's enough points. If you want to get additional points, you can. If I went over 3, how much would I go up? What's 3 squared? What is 3 squared? 9. So I could go over 3, up 9 from my vertex if I wanted additional points as well. I'm going to sketch my graph of my quadratic. But I still need to answer all of this information about the key features. So where is the axis of symmetry? Remember, it goes right down through the vertex, cutting that parabola in half. So that is, remember, it is always x equals h. So in this case, it's x equals 2. Okay. What is the domain of this graph? What's the domain of all quadratics? We said all real numbers. All quadratics have a domain of all real numbers, negative infinity to positive infinity, because they all open left to right forever. Okay, whether it's opening up or down, or it's been shifted or stretched or compressed, it's still going to be opening, and these are going to be getting wider, wider, wider. So left and right forever. Hey, what about the range? How low to how high does this graph go? Yeah, range is the y values. How low does it go? It's at -3. So it goes up from -3, how high? To infinity. And we include the -3. So we put a bracket there. All right, what's the y-intercept here? I can see the y-intercept on my graph. Yeah, it's at 1. So it's at 0, 1, because I went over 0, up 1. Now these x-intercepts are fractional values or decimal values. I don't have a point plotted exactly where they are, so I would need to just get those. I could go, if I typed this in Desmos and looked at the graph, in Desmos, you can just go and click on the x-intercept, and it will tell you the value, the ordered pair. So I'm going to go ahead and just tell you the x-intercepts are at approximately 0.27 and 3.7. All right, increasing and decreasing intervals. Remember, increasing and decreasing, we say we read the graph from left to right. So from left to right. Is it increasing or decreasing first? Decreasing, it's coming down, and then it turns and it's increasing. So from left to right, we're talking x values. It's decreasing first, from negative infinity until that vertex where the x is 2. Then it's increasing from 2 to infinity. So again, if you need to give yourself a little reminder, we're using x values here. It's left to right. Now I listed A over here already, and I know I said H and K up there when I listed the vertex, but I'll go ahead and just list them here as well. So the H was 2 and the K was -3. So what does that mean for my horizontal shift? How did this graph shift horizontally? So if the vertex and the parent function is at 0, 0, normally starts here at 0, 0, how much did this shift horizontally, left or right? It shifted right, how much? 2. Okay, it's your H value. Okay, so your H was 2. This went right 2. Okay, what about your vertical shift? How much did this shift vertically off of the origin? Did it go up or down? Down. Down how much? Down 3. All right, and then it said, what do you think the value of A is? We already identified A as 1. Okay, we did that up here from the equation because A is what's multiplied in front. Now, is this function continuous or discontinuous? Continuous. Okay, all of our quadratic parabolas here, these are all going to be continuous graphs. Okay. All right, let's try one more example like this together. Okay, we're going to go through the completing the square process so we can get it in vertex form so that we can graph it and answer the information about it. And again, I don't really like the way that they did this, so I'm just going to mark this out, this parentheses squared. I like to just have, the way we were practicing was just with plus blank. So we'll go ahead and find our b divided by 2 squared up here. Okay, I think that is better. All right, so the first thing we need to do is move that constant, that 13, to the other side. So it becomes -13 on that side. Which I'll go ahead and copy all of that down. So we've got x squared plus 8x plus blank equals -13 plus blank. So what is the b value here? The 8. Good. So I'm going to take 8 divided by 2 and square it. So 8 divided by 2 is 4, and 4 squared is 16. So 16 is what I'm adding to both sides. Okay, so when I go to factor this, okay, what multiplies to 16 but adds to 8 is 4. Okay, positive 4. Okay, again, that came from half of b right here. Okay, so that is x plus 4 squared. And then on the right side, I need to condense this, combine like terms. What is -13 plus 16? It's just a 3. Now, to get this in vertex form, how do I move that 3 back to the left side? What does it become? Good, it becomes -3. So let's identify our A, H, and K here. What is the A value? The 1. A is what's multiplied in front there. Both of these had A values of 1. And you can see your A value when it was in standard form up here. Remember, it's AX squared plus BX plus C. We could see here A was a 1. Okay, so A was just the 1. What's H? -4. Okay, because remember, H is the opposite sign of what you see in the parentheses there. and then your K is -3. So what does that mean for we can go ahead and answer these shift questions first while we're talking about A, H, and K. So what is the horizontal shift? Left 4, because H is -4. Okay, what's the vertical shift? Down 3. K is -3. We said A was 1, and we said this function will be continuous. Okay, so let's go ahead and plot. If I go left 4, down 3, that's where my vertex is. Okay, so I plot my vertex. I'll go ahead and write that up here. So we're at -4, -3. Now, since A is a +1, this is going to be opening up again. So that's going to be a minimum value again. Okay, now I could go to Desmos and type this in and make a table, however you want to do it. But I know my A is 1, so from my vertex, I know I'm going over 1, up 1. Going over 2, up 4. Okay, I'm going over. Now, I want to know the y-intercept. It's one of the questions. So I'm going to go ahead and see if I can plot that here too. From the vertex, if I go over 4, how much should I go up? What's 4 squared? I should go up 16 from -3. That would put me up at like 13. So that would be off my graph. Okay, but I know that's going to be at 13. So I can go ahead and put that. Or I could get that from Desmos if I needed to. Okay, but to get over to the y-axis from your vertex, it'd be over 4. So 4 squared is 16. So if I go up 16 from -3, that would put me at 13. That's how I got that. Okay, so let me go ahead and sketch this curve. Again, whoa, why are you deleting? Again, I don't have points plotted on my x-axis, so I don't know their exact values from points that I plotted. They're going to be decimal or fractional values. So I'll just go ahead and tell you again what those come out as to save us some time. So that comes out to approximately -5.7 and -2.3. And again, you would just go in Desmos and click on those to get those. Okay, what about the increasing, decreasing intervals here? Left to right, my graph decreases first, and then it turns and is increasing. So I'm going to say it's decreasing from -infinity to the x value of -4. And that's where it turns and then is increasing. Okay, what am I missing up here? Axis of symmetry, right down the middle, right? So that's at x equals what? X equals -4, good. Okay, and then my domain for all quadratics is always all reals. I know that one. Now what's the range here? How low to how high does this graph go? Yeah, it's your K value is your low. So -3 to infinity. Your range is always either going to be K to infinity if your vertex is a minimum, if it's opening up, or it's going to be -infinity to K if your vertex is a maximum, if your graph is opening down. You'll feel okay about these? So again, it mixes the completing the square process we did Thursday, Friday with the graphing, transformation, key feature stuff we did earlier last week. So it's putting it all together, bringing it all back. Okay, this one says if we are given vertex form of the equation with no numbers, just A, H, and K, we want to identify the following. Okay, so what is the domain always for all quadratics? Yeah, I don't even need numbers in there. If I know it's a quadratic, I know it's all real numbers for the domain. Okay, and then what I just told you for the range, what is this A? This A is positive, right? There's no negative in front. So what's the range going to be? What's going to be the lowest Y value? The K, whatever K is. So it's going to be K to infinity. And you'll include the K, whatever it is. What's the vertex? HK. What's the axis of symmetry? X equals H. Don't forget it, we write it as an equation. But that's it. So, I mean, this is to know without any numbers, whatever numbers end up in here in vertex form, you know the range, the vertex, and the axis of symmetry. Feel okay about this? All right, so we're going to have a little practice assignment over this. We've got about 17 minutes to practice. You have not finished one of the practice assignments from last week. You may want to finish that up first before starting the new one. Okay, keep an eye on those deadlines in Delta Math. Remember, we're in a new 9 weeks, so stay on top of those grades.